When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the Earth was flat. About 150 AD, Ptolemy presented the geocentric theory, the belief that the Earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the Earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion, known as orbital mechanics.
Not everybody can be a robot polisher.
In the early 1600s, Johann Kepler developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits with the sun at one focus and the other focus empty.
Kepler's second law, the law of areas, states,
the line joining the planet to the sun sweeps over equal areas in equal time intervals.
When a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth.
You are moving 1,000 miles an hour as Earth rotates, and that's fast. I mean, that's faster than you would ever be going in anything in your life. You are moving 18 miles per second in orbit around the sun.
With all these rotations and revolutions, you are probably wondering, why don't I feel the Earth move?
Earth were turning and moving, we'd feel it.
Right.
Okay? Why wouldn't you feel?
The answer is quite simple. We do not feel any of this motion
Because first, Earth connects you to its surface, but also you're moving very uniformly.
these speeds are constant. The spinning and orbital speeds of Earth stay the same, so we do not feel any acceleration or deceleration.
And the air around you is moving with you. So it's not like air is coming past you at 1,000 miles an hour and you feel, oh my gosh, I'm in motion and I feel the jiggle and the shake.
You can only feel motion if your speed changes. Earth revolves around the sun at an average speed of about 27 kilometers or 17 miles per second. But the speed is not constant. The planet moves slower when it is at aphelion,
point farthest from the Earth,
and faster when it is at perihelion.
point in the orbit closest to the Earth.
We do not feel any of this motion because these speeds are constant. But the speed is not constant. The planet moves slower when it is at aphelion and faster when it is at perihelion.
We do not feel any of this motion because these speeds are constant.
But the speed is not constant. But the speed is not constant.
But the speed is not constant.
So clearly Earth can't be moving. Of course we're not rotating either. Everything is moving around us. It kind of made sense when you thought about it. When you thought about it.
When you thought about it.
Not everybody can be a robot polisher.
The faster you rotate, okay, the greater is the centrifugal force that will operate on you. It's trying to fling you off the Earth, okay, but the force of gravity is resisting back. By what force is it trying to fling you off? That upward centrifugal force subtracts from the gravitational force that the Earth is trying to put on you. It subtracts. Okay, so Chuck, what do you weigh here and now? 192 pounds. 190 pounds, okay? Okay. So if you do the math, you run to Ecuador will not be 190 pounds. You'll be like 185 pounds. What? That's how significant it is. There are pounds less that you weigh simply because the spinning Earth is trying to fling you off.
Nice.
Yes.
This is really cool.